Dilations are the fourth and final transformation in our transformations unit. First, I want you to just think about the word dilation. Where have you heard this word before? You know when they explain that your pupils dilate, the pupils in your eyes, they get bigger or they get smaller, but they stay the same shape? That's what a dilation is. It's when a shape gets bigger or smaller, but it's still the same shape. Kind of like similar triangles, right? So let's look at this example problem. It says, example 1, r equals 1/2. R, let's make that a little neater. Okay. R is called the dilation factor. It is the amount that you are either shrinking or enlarging the figure. So it says here that r equals 1/2. Whenever r is greater than 1, the shape gets bigger. Whenever r equals 1, the shape stays the same. And whenever r is greater than 0 but less than 1, aka a decimal or a fraction, the shape will get smaller. So over here we are walking you through an example. First, we're going to connect the center, this is the center right here, with each vertex, remember what a vertex is, of your figure. So we have a line going from the center to each vertex. Step 2, use the scale r equals 1/2, which means that the figure will be smaller than the original. So you would measure the distance from here, the center, to the first vertex, and then, oh wait, no, hold on. You would measure the distance from the center to D prime, and then you would divide that by the distance from the center to D in order to get R. So, that's just how you get R, just so you know. And then step 3, we connect the new points, so these points here, to the vertices of the new figure. Oh wait, these points here, we connect them to make the new figure. So here, let's do this first one. It says, draw the dilation of the figure if r equals 3/4. So let's think of r equals 3/4. That is a fraction. So r is going to be less than 1. Therefore, the shape is going to be getting smaller. If r is less than 1 but greater than 0, it's going to be getting smaller. So r equals 3/4. So the first thing we do, we connect each one of the vertices in the shape to the center. Okay? Sorry, that line didn't come out all the way, but okay. Sorry, it's very hard to draw straight lines on this program because I'm using a stylus, so I'm doing my best. So now that you've connected, all of your vertices to the center, you have to measure the distance from the center, O, to the first vertex. And it looks like it's about 4, and it looks like it's about 12 centimeters. So from O to A, we have 12 centimeters. And then just do the same thing for each vertex line that you made. So from O to G, it's 10 centimeters. From O to F, 10.5. From O to C, 12 centimeters. From O to B, it's 13. From O to E, it's 9.5. And then from O to D, it's 11.5. So now, if we have a scale factor, or if R is 0.75, let's just use a decimal because it's easier to multiply things by decimals. If this is our dilation factor, we're going to multiply it by each one of these in order to find where we're going to put the new vertex. So let's multiply each one by 0.75. And we will get the length of our new segment. And I'm going to do just some quick calculations. So I'm going to put the new side length in red. Okay, 9 centimeters. Okay, so now we have the measures of from the center to the new vertex. And that's how we know where to put the vertex on the guidelines that we made. So on the first guideline, it extends from the center to vertex A. So now I'm going to find where to put A prime. And A prime will be at 9 centimeters. Make sure you label. Okay. G is the next one that we did. The new G vertex will be at 7.5. F is the next one. It's 7.875. Over here. And C is right here. C was 9 centimeters. Remember, you're going to have different numbers because I copy and pasted this this figure. So I blew it up. You're going to have different sizes of your sides. 9.75. Right here. B prime. And then E is going to be 7.125. And then D prime is 8.625. D prime. And then connect the vertices, the new vertices, in the order that they are above. So A connects to G, and then A connects to B. You can start from the top down. Okay. I don't know why this line won't draw. Okay, there we go. And then, oh, because I was drawing another line over there. Great. Okay, so A connects to B. And then G connects to F. Wait, C connects to B. F connects to E. Wait, what was F? F was... .875. So F is going to be up right about here. Miscalculated that one. Okay. G connects to F. F connects to E. And C connects to D. And we get our new shape. And it's about 3/4 of the size of the large shape. So we know that we calculated everything correctly. Let's do the dilation of this figure. So this time, dilation factor equals 3. Now remember, if the dilation factor is greater than 1, the shape is going to get larger by roughly that amount. So the new shape is going to be about 3 times as big as the first shape. So let's connect all of the vertices to the center. Now in this case, if we're making a larger shape, and we already know that beforehand because of the size of R, let's extend the lines a little bit past the shape. Okay? Okay. So now, remember, we want to measure the distance from the center to the first point. And the distance from 0 to A is about 2 1/4 centimeter. And the distance from O to D is about 4 centimeters. The distance from O to B is 3 centimeters. And the distance from O to C is 4 centimeters. So remember before we just multiplied the scale factor by each length? We're going to do the same thing again. Multiply by the scale factor, in which case the scale factor is 3. So let's do our math. We get 12, 9, 12, 6.75 centimeters. So let's measure those out for our new vertices. So along the A guideline, I'm going to measure 6.75 centimeters. That's going to put me right about here. Okay, A prime. Along the B guideline, I'm going to measure 9 centimeters. It's going to put me right about here. Along the D guideline, I'm going to measure 12 centimeters. Puts me right here. And then on the C guideline, I'm going to need 12 centimeters, which puts me off the map, somewhere around there. Okay, so I connect my points. And I'm going to get a shape that goes off the screen but looks like this. Okay, and that, the new shape, A prime, B prime, C prime, D prime, is about 3 times bigger than this. So our dilation factor makes sense. Now what about if R equals 1? If R equals 1, remember, the shape stays the same. Let's see. Let's connect each of our vertices to the center point. And I'm going to prove it to you. Okay. So let's measure the distance from center O to vertex A. It's going to be 5.5 centimeters. From O to F, O to B, O to E, O to C, O to D. So from O to F, it's going to be about 4.5 centimeters. From O to B, it's going to be about 7.5 centimeters. From O to E, 5 centimeters. O to C, 8 centimeters. And O to D, 7.5 centimeters. Okay, now let's multiply each side by the scale factor, which is 1. Now wait a second. Anytime we multiply something by 1, it is equal to itself, right? So the length from the center to the new vertex from O to A prime is going to be 5.5 centimeters. So on and so forth for each one. So if I measure the distance, I'm going to get A prime is here, B prime is here, C prime is here, D prime is here, E prime is here, and F prime is here. And that is the original shape. So whenever R equals 1, the shape stays the same. This is a summary of everything you should know by the end of this lesson. When R is greater than 1, the figure gets bigger. When R is a decimal or a fraction, the figure gets smaller. And when R equals 1, the figure stays the same. What if you have to do the opposite? What if they give you 2 figures and you need to figure out what R is? That's called finding the dilation factor. Look at this example here. We have to find the center and we have to find the dilation factor if we have the original figure and the image figure. Okay? So first, look at the 2 figures, right? Here's the original. I know that because it doesn't have the prime symbols. And then here is my image figure. I know that because it has the prime symbols, okay? So I need to just first kind of determine a relationship between the 2, right? Is the image figure bigger or smaller than the original figure? Well, in this case, the image figure is bigger. What do we know about R? When the image figure is bigger than the original, R has to be greater than 1, right? Okay, so let's use that hypothesis to test in this one. So here it says step 1, connect the corresponding vertices of the 2 figures. Okay, so this is kind of just the same thing we did before. We're going to connect them off to some center point out here named O. And now we have to divide the distance from the center to the image vertice by the distance from the center to the original. So look at this one up here, right? The distance from the center to A prime, so from O to A prime, is 5 centimeters. The distance from the center to A original is 3 centimeters. Now the problem tells us that we have to divide this number here by this number here, and we're going to find the dilation factor. So the dilation factor here is going to be 5 over 3. And that makes sense because 5 over 3 is an improper fraction, so it's greater than 1, and therefore the figure is going to be getting bigger. And the image figure is bigger, so that makes sense. Let's find the center and scale dilation of this one. Okay, so first I need to connect my two vertices to a center point O off to the side. Let's do right. Oh my, what is that? Why is it doing that? Okay. Let's do this. Connect the B's. Okay, I'm just going to have to do it freehand. The ruler's not working. Sorry. Make sure you do yours with a ruler because it makes it really hard if it's not neat. Okay, C. And the point where they all connect is called center O. So now, remember, we found the distance from the center to A prime, and that is 7 centimeters. So from the center to A prime, we had 7 centimeters. From the center to A original, we had 13.5 centimeters. Okay, so remember we divide 7 divided by 13.5, and we get 0.5. Let's round. We'll get 0.52. Okay? Let's see if we get that for the other ones. So we're going to measure the distance from B prime now to center O and get 8.5. No, let's do a different color. Okay. Now we measure the distance from the center to B original, and we get 15.5. And we divide those, and we get 'Okay. Now let's do the C's. Measure the distance from the center to C prime, and we get 7.5. Measure the distance from the center to C original, and we get 14. Divide those two by each other. We get a 0.53. Now let's measure the distance from center to D prime. We get 6. From the center to D original, we get 12. 0.5. So we all basically got 0.5. The reason why my numbers are kind of off is because I wasn't able to use a ruler given the way that the program is set up, okay? But generally, we got a dilation factor of R equals 1/2 or 0.5. 5. And that's how you find the dilation factor. I think we've done enough.